This is a question from February-March 2016, question 4. Hydrogen peroxide decomposes into water and oxygen in the presence of a catalyst. The catalyst being used here is manganese oxide. So let's read the information given. A student studies the rate of decomposition of hydrogen peroxide using the apparatus shown. The student uses 20 centimeter cube of 0.1 mole dm cube hydrogen peroxide and 1 gram of manganese oxide, which is the catalyst. So the student is measuring the volume of oxygen given off at a regular time intervals. Now as you can see here, as the hydrogen peroxide decomposes, what goes inside here is oxygen, and as the syringe moves, it will determine how much or what is the volume of oxygen gas is being collected. So in this graph we can see that as the time goes by, the volume of oxygen increases at a high rate, and after a certain point of time it stops increasing. So the question 1 and 2 is asking you about rate of reaction, which is in chapter 7. And if we move on to question C, they're asking you to calculate the number of moles for hydrogen peroxide used in this experiment. So I'm just going to write down the information that was given in the question, whereby 20 centimeter cube of 0.1 mole dm cube concentration of hydrogen was being used. So since the question is asking you to find the number of moles, let's first look at the information that we have, which is volume and concentration. Now this is the standard formula of finding a concentration for a substance when the information is between mole and volume. And if we can see, based on the question, we have already been given the information for concentration. That means you can substitute 0.1 mole dm cube into your concentration. However, as you can see here, this value is based on dm cube. So the first thing you gotta do for the volume here is change it to dm cube. So centimeter changing to dm cube is dividing by 1000. Once you have divided it, you will get 0.02 dm cube. And now you have to find the value of mole. So the value of mole would be that volume multiplied by concentration. After cutting them, you can get 0.002 mole. So this would be your answer for hydrogen peroxide. Now moving on to question 2, using your answer in CI and the equation, calculate the number of moles of oxygen produced in this reaction. Now that you have obtained your mole for hydrogen peroxide, what you have to do is compare the ratios from the equation. From this equation, we can determine that 2 moles of hydrogen peroxide would produce 1 mole of oxygen. So in that case, if I have 0.002 mole of hydrogen peroxide, what would be the number of mole for my oxygen? So after doing a comparison, you would get that the mole of oxygen would be 0.001. Now for the last question, they're asking you to calculate the volume of oxygen produced. So let's gather up the information that we have for oxygen first of all. So the only information that we have is the number of mole, and from the number of mole we are trying to find the volume. Now if you refer to the notes that I have uploaded, if you have the number of mole and you would like to find the volume, the connection is that you need to multiply with the room temperature, which is 24 dm cube. So if you multiply 0.001 mole with 24 dm cube, you will be able to get 0.024 dm cube of oxygen. Now question 4 is asking you what would be the effect on the volume of oxygen produced if the mass of catalyst was increased. Now this question is also not exactly related, however I'll just give a brief explanation. Amount of catalyst has nothing to do with the rate of reaction, therefore there will be no change. Question 5 is about this chapter as well. They're asking you to deduce the volume of oxygen that would be produced if 20 centimeter cube of 0.2 mole dm cube was used instead of 20 centimeter cube of 0.1 mole dm cube. So as you can see, what happening here is that they have increased the concentration by 2. If they have increased the concentration by 2, your number of mole will also be increased by 2, giving you 0.04, which means that this would be 0.004, giving you 0.002 mole of oxygen, and this is doubled as well, giving you a double volume of 0.048 dm cube. Question 5. Chlorine, bromine and iodine are halogens. Now halogens are the name that they give for group 17. Question A. Chlorine can be made in the laboratory by heating manganese oxide with concentrated hydrochloric acid. So calculate the volume of 8 mole dm cube HCl needed to react with 3.48 gram of manganese oxide. So when you get information about the question, please always write whatever information that you have on top of the equation. So these are the information that has been given. The first question is asking you to find the moles of manganese oxide. So as you can see here, they have given you the mass and they want you to find the number of mole. So if you refer to the notes, you would see that when you have the information for mass and you need to find the number of mole, what you need to do is divide it with the relative atomic mass. Now the relative atomic mass for manganese oxide would be 55 for manganese, and oxygen has the relative atomic mass of 16. Since it is diatomic, you need to multiply it with 2. Now you will get a total of 87. So this means that in order to find the mole, the mass of manganese oxide, which is 3.48 gram, will be divided with 87. After dividing, you'll be able to get a number of mole of 0.04. So this is your answer for moles for manganese oxide. Next, they're asking you to find the mole of HCl. Now, similar with the question that we did before, if 1 manganese oxide gives you 4 HCl, then all you have to do is compare the number of mole according to this ratio. So 0.04 mole would give you 0.16 mole of HCl. So that would be your answer here. Now the last question is asking you to find the volume of HCl needed. Now first of all, let's list down the information that we have for HCl. Now you have the mole and the concentration for HCl. All you have to do is find the volume. So using the same formula with the previous question, in order to find the volume from concentration and mole, you have to divide it with each other. So 0.16 mole will be divided with 8 mole dm cube to give you 0.02 dm cube. However, they want the answer to be in centimeter cube. Therefore, dm cube converting to centimeter cube means you have to multiply it with 1000, and your final answer would be 20 centimeter cube. Now this is the question from February-March 2017, question 6. It says that barium carbonate decomposes when heated. It gets barium oxide and carbon dioxide. A student heated a 10-gram sample of barium carbonate until it was fully decomposed. Calculate the number of moles of barium carbonate the student used. Now for this question, you have the mass and you would need to find the mole. And as we have done the previous two questions before, referring to our notes as well, if you have the mass and you need to obtain your mole, what you need to do is divide it with the relative atomic mass. If you add up all the elements of barium carbonate based on the periodic table value, you would get a total of 197 for barium carbonate. So the mole of barium carbonate will be 10 gram, the mass divided by its relative atomic mass of 197, giving you a value of 0.05 mole. Now question 2, calculate the volume of carbon dioxide gas produced at room temperature and pressure. Give your answer in dm cube. Now we're going to answer this question the same way that we did previously. 1 barium carbonate will produce 1 carbon dioxide. This means that if you have 0.05 mole of barium carbonate, you also have 0.05 mole of carbon dioxide. Now from mole to convert it to volume, what you need to do is multiply it with your condition of room temperature and pressure, which is 24 dm cube. This will give you a value of 1.22 dm cube. Now question B is saying that the student added 2 gram of the barium oxide produced to water. Calculate the mass of barium hydroxide. So they're looking for the mass that can be made from 2 gram of barium oxide. So we know that the mass for barium oxide is 2 gram. And they also gave you the relative atomic of barium hydroxide, which is 171. So I'm going to write it here. Now we know that the relative atomic mass for barium hydroxide, if you calculate based on your periodic table, you would be getting 153. So what we can do is a comparison, since 1 barium oxide will produce 1 barium hydroxide. Now if the relative atomic mass of 103 requires 2 gram, This means that you could do a cross multiplication like this to find the mass of barium hydroxide. So you would be getting 2.24 gram of barium hydroxide. All you had to do was just use the ratio to find out if 153 gives you 171, then 2 would give you 2.24. Now question C. A 1.5 gram sample barium hydroxide was dissolved in water. The total volume of the solution was 100 centimeter cube. So they're saying that a 25 centimeter cube portion of the barium hydroxide solution was titrated against HCl. The volume of HCl required was 18.75 centimeter cube. Now titration means you have roughly about 25 centimeter cube of barium hydroxide, and after titration, in order to neutralize it, we only used up 18.75 centimeter cube of HCl. So the question is saying barium hydroxide adding up with HCl, you get barium chloride and water. Calculate how many moles of barium hydroxide were in the 25 centimeter cube portion used. So before we answer the question, let's write down all the information given underneath this chemical equation. So in order for us to find out how many moles of barium hydroxide is inside this volume, all you have to do is mole is equals to mass over molar mass. So the mass given here is 1.5 gram, and the molar mass has already been given over here, whereby it is 171. Now if you divide them, you would get a number of mole which is 0.008. However, this 0.008 value was actually for the total volume of the solution which was used, which is 100 centimeter cube. However, in this portion, since we are only using 25 centimeter cube, it means that we have to divide the number of mole accordingly as well, which is by 4. So you would be getting a number of mole which is 0.002 mole. So that would be your answer for the moles of barium hydroxide. Now the next question is asking you to calculate the concentration of hydrochloric acid used. So if 1 barium hydroxide gives you 2 HCl, then 0.002 barium hydroxide would give you 0.004 mole of HCl. Now that we've got the number of mole for HCl, we can find the concentration. The formula for concentration is mole over volume. So the mole here is 0.004, and the volume would be that, as mentioned here, we have used 18.75 centimeter cube. However, you need to convert it to dm cube first, and you would get 0.01875, which is divided by 1000. After calculating this value, you will be able to get a concentration of 0.234. This is the question from May-June 2017, question 5. So question 5A is not related to this chapter, however B is. It says that a sample of vanadium chloride was weighed and dissolved in water. An excess of aqueous silver nitrate, acidified dilute nitric acid was added. A precipitate of silver chloride was formed. This is the ionic equation that they have given you. The mass of silver chloride formed was 2.87. State the color of the precipitate. So this one is from a different chapter. Let's move on to question 2. It says that the relative formula mass of silver chloride is 143.5. Calculate the number of moles in 2.87 gram. Now if you have already been given the mass and the relative atomic mass, the formula that you need to use is the one where mole is equals to mass over molar mass. So if you substitute your value, you would get a mole of 0.02 mole. Question 2. Use your answer in BI and the ionic equation to deduce the number of moles of chloride that produces 2.87 gram. Again, you have to do comparison for this. Now as you can see here on the equation, the ratio of silver ion is 1:1 with chloride ion. This means that number of mole will also be equal, which is 0.02. Question 5. The amount of vanadium chloride in the sample was 0.01 moles. Use this and your answer in B3 to deduce the whole number of ratio of moles vanadium chloride to the moles of chloride ions. And then you need to determine the formula of vanadium chloride. Now the moles of vanadium chloride is already been given there for you, which is 0.01 mole. And the mole of chloride ion which you found was 0.02 mole. So we can say that for each 1 vanadium chloride, you would get 2 chlorine atoms. So your formula should be 1 vanadium and 2 chlorine, so it gives you vanadium chloride 2. Now this is a question from February-March 2019. Question 1 is not related to this chapter, so we'll be moving on to question B. Calculate the volume of chlorine gas at room temperature and pressure that reacts with completely 400 grams of titanium oxide using the following steps. So the first step is asking you to calculate the relative formula mass, which is simple. All you have to do is get the value of the mass from their periodic table. As you can see here, titanium has a relative molecular mass of 48 and oxygen has a relative atomic mass of 16. Please don't take the bottom value, as the bottom value is a proton number and not your relative atomic mass. So you have got 48 for titanium and 16 for oxygen, and since there are 2, you need to multiply it by 2, giving you a total relative formula mass of 80. Now the next step is to calculate the number of moles in 400 grams of titanium oxide. This is simple as well. As I mentioned before, in order to calculate mole, when given mass and molar mass, all you have to do is divide them. So your mass is 400 grams and you have to divide it with your relative atomic mass, which is 80. This will give you a value of 5 moles. The second last step is asking you to determine the number of moles for chlorine that react with 400 grams. Now let's look at the chemical equation to look at their ratio. If 1 titanium oxide gives you 2 chlorine, it would look like this, 1 to 2. So 1 titanium oxide has 5 mole, that means 2 chlorine would give you 10 mole. Now they're asking you to calculate the volume. If you have mole and you would like to find volume, all you have to do is multiply it with the room temperature or condition, which is 24 dm cube. So 10 mole multiplying with 24 dm cube would give you 240 dm cube. This is the question from February-March 2018, question 2. C is not related, so I'll be skipping to the fourth question. It says that the student started with 20 centimeter cube of 2 mole dm cube NaCl. Determine the amount of NaCl used, meaning they want us to find the mole. In order to get the concentration, the mole has to be divided by volume, given that the volume is in dm cube. So the first thing you need to do is convert 20 centimeter cube to dm cube by dividing 1000, and you will be able to get 0.02 dm cube. Since your concentration is 0.2 mole dm cube and your volume is 0.02 dm cube, you can multiply them with each other to get the number of mole, which is 0.004 mole. It says that the yield of sodium nitrate crystals was 90%. Calculate the mass of sodium nitrate crystals made. Now first of all, let's calculate the relative atomic mass of sodium nitrate. After adding up the relative atomic mass from the periodic table, you will be able to get 85. So looking back at your equation, 1 NaCl gives you 1 NaNO3. So this means that 0.04 mole of NaCl will give you 0.04 mole of sodium nitrate as well. So in order to find the mass, all you have to do is multiply your mole with molar mass. So the mass that you will be able to obtain would be 0.34 gram. This is the question from May-June 2019, question 5. Copper 2 sulfate crystals are hydrated. Now hydrated means that they contain water. That is why you have 5 H2O over here, meaning 5 molecules of water. Copper 2 sulfate crystals are made by reacting copper carbonate, which is CuCO3, and with dilute sulfuric acid, which is H2SO4. Now dilute means it contains a high amount of water. The equation for the overall process is shown. As you can see here, we got copper carbonate, sulfuric acid diluted with water, and you've got your copper sulfate crystals with carbon dioxide. So they have explained 5 steps over here on how to make the salt. So as you can see, there are 5 steps here on how the crystals are formed. So we'll be moving on to the first question. It's asking you to calculate the maximum mass of the copper 2 sulfate crystals that can form using the following steps. So the first step is you need to calculate the number of moles for H2SO4 in 50 centimeter cube of 0.05 mole dm cube sulfuric acid. So as you can see here, they have already been given you the concentration which is in dm cube, which means that you have to change your volume to dm cube. If you do that by dividing to 1000, you would get 0.05 dm cube. Now as you can see here, we have come across this formula before, where concentration is equals to mole over volume. We have a concentration of 0.05 mole per dm cube from the unknown mole of 0.05 dm cube. So in order for us to find the mole, you have to multiply the concentration with the volume, which will give you a value of 0.0025 mole. The next question is asking you to determine the number of moles of copper sulfate hydrated crystals that can form. Now that you have found the mole for sulfuric acid, what you can do is, as usual, always compare the ratio. If 1 sulfuric acid gives you 1 copper sulfate crystals, this means that the ratio is 1 to 1. So this means that 0.025 sulfuric acid will also give you the same amount of hydrated copper crystals, which are 0.025 mole as well. So that would be your answer. Now the last question is asking you to calculate the mass for copper sulfate crystals that can form. They gave you the relative atomic mass here. So as we know, mole is equals to mass over the relative atomic mass. Since you have got the mole here, which is 0.025, and your relative atomic mass, which is 250, what you need to do is multiply your relative atomic mass, which is 250, with the number of mole. This would give you a mass of 0.625 gram. Please don't forget to write your answer over here as well. This is the May-June 2020 paper, question 5E. The equation for the decomposition of hydrogen peroxide is shown as below. It says that 25 centimeter cube of aqueous hydrogen peroxide forms 48 centimeter cube of oxygen at room temperature. Calculate the concentration of aqueous hydrogen peroxide at the start of the experiment using the following steps. So the first one is pretty simple. All you have to do is calculate the number of moles for oxygen. You have already been given the volume. I hope you have already memorized this triangle by now. If you have given the volume and you want to find the mole, you have to divide it with 24 dm cube. However, before you divide it with 24 dm cube, please check your units which has been given for oxygen. It has stated here that it is in cm cube. So if you change it to dm cube, you need to divide it by 1000, giving you a value of 0.048 dm cube. So now in order for you to find the moles, 0.048 dm cube will be divided with the room temperature and pressure, which is 24 dm cube, giving you a value of 0.002 mole. The second part is asking you to deduce the number of moles of hydrogen peroxide. So similar like how we did previously, you just need to compare the number of ratio. It states in the equation that 2 hydrogen peroxide gives 1 oxygen, and as we know, the number of mole for oxygen is 0.02. Since the ratio is difference by multiplication of 2, you just need to do the same thing and you would get a number of mole which is 0.004. So that is your answer. So for the final part, they're asking you to calculate the concentration for hydrogen peroxide in mole dm cube. As we know, concentration is mole over dm cube, the volume. We already have the information for both mole and volume. Mole, as we calculated, we got 0.04, and the volume has been given in the question, which is 25 centimeter cube. However, as usual, you need to convert this to dm cube, giving you 0.025. So just substitute the value here. Now if you calculate this, you will be able to get 0.16 mole dm cube for the concentration. This is the question from specimen paper 2020, question 6b. It says that 5.95 gram of cobalt carbonate were added to 40 centimeter cube of hydrochloric acid. The concentration given here is this 2. They're asking you to calculate the maximum yield of cobalt chloride 6, which is this one. and show that the cobalt carbonate was in excess. So they have given, this is pretty simple because they have given you what you should do step by step, and the first part is asking you to calculate the moles. Now please check what information have been given for HCl. So they gave you the volume and also the concentration, and you need to find the mole. So that's easy. First convert this into dm³ by dividing it to 1000 and it will give you 0.04. Since you have got the volume and the concentration, just multiply them with each other and you would get 0.08 moles. It's not necessary to write moles here, however, if you still want to write it, it's fine. So the next question is asking you to find the number of moles for cobalt chloride. Again, all you have to do is compare the ratio. HCl has 2 and cobalt chloride has 1. So it's a 2 to 1 ratio, meaning that you have to divide this by 2 as well, giving you 0.04 moles. Next is the number of moles for cobalt chloride with 6 molecules of water. As you can see here, the ratio is also 1, which means that you will have a similar number of moles as well, which is 0.04. Next, they have given you the mass for 1 mole, which is 238 grams. Now, since we only have 0.04 mole, we need to calculate what is the mass for 0.4 mole. If 1 mole gives you 238 grams, what would be the mass that you obtain only from 0.04 mole? If you do cross multiplication, you will be able to get a mass of 9.52. The next question is asking you to show that cobalt carbonate is in excess. First part is asking you to find the number of moles of HCl. Use the value from above. So it would be same technically, which is 0.08. It says here that the mass of 1 mole is 119 grams. So it also says here that the number of moles in cobalt chloride in 5.95 grams of cobalt carbonate is, so we already have 5.95 grams here that we know of. So this is reversed with the previous question. This one you need to find what is the number of mole, which will give you, after doing a cross multiplication, a value of 0.05 mole. So since you have 0.05 mole existing in 5.95 gram, and the calculation here shows that there are only 0.04 moles. However, you can actually find 0.05 mole because we are using this much of mass. So this means that 0.05 have exceeded 0.04. This shows that this is in excess. This question only gives you 1 mark. If you just mention 0.05 is more than 0.04, you are able to get the full mark. However, I have just written here a brief explanation saying that this shows that the existing cobalt carbonate used is more than the calculated value. So this is the proof that this is in excess. This is the specimen paper of 2023, question 4. In a titration. Now titration is a method for neutralization. Says that a student added 25 cm³ of 2 mole dm³ aqueous sodium hydroxide to a conical flask. The student then added a few drops of methyl orange. Methyl orange is an indicator to the solution in the conical flask. Dilute sulfuric acid is then added from a burette to the conical flask. The volume of dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide is 20 cm³. This is the equation that has been given. They want you to find the color of methyl orange in aqueous sodium hydroxide. Now aqueous sodium hydroxide is an alkali, and methyl orange and universal indicator would turn yellow when the solution is a base or alkali. Now question 2 is asking you to determine the concentration of the dilute sulfuric acid in gram dm³ using the following step. So the first step, we need to find out the number of mole for sodium hydroxide. Now let's look at the information that has been given for our sodium hydroxide. We have the volume and the concentration. So this one is easy. First step is to convert your volume into dm³, and this would give you a value of 0.025. And in order to achieve the number of moles, all you have to do is multiply it with the concentration given here. After multiplying with each other, you will get a value of 0.005 mole. The next step is asking you to calculate the number of moles for dilute sulfuric acid. Now that you have the mole of sodium hydroxide, you have to refer back to your equation and check the ratio. 2 sodium hydroxide gives 1 sulfuric acid. This means the ratio is 2 to 1. So if you have 0.05 mole, the ratio would be to divide by 2, giving you a mole of 0.025 mole. Now the next step would be to calculate the concentration of dilute sulfuric acid in mole dm cube. Since you already have the number of mole and the volume given here in the question, all you have to do is divide it with each other. But first, do not forget to change this into dm cube by dividing 1000, and you would get 0.002 dm cube. After dividing 0.0025 mole with 0.02 dm cube, you will be able to get a value of 0.125 mole per dm cube. Now the final step would be to change the concentration that you have in mole per dm cube into gram per dm cube. Now you can multiply the mole per dm cube with gram per mole, and if they cut with each other, you can see that you will be able to obtain gram per dm cube. Now gram per mole is the value of relative atomic mass of sulfuric acid. After adding up the relative atomic mass of sulfuric acid, you will get a value of 98. Multiplying with the concentration that we have obtained before will give you a value of 12.3 gram per dm cube. This is the question from February-March 2018, question 4. So question A is not related to this chapter, and I will skip to question B. Question B says ammonia react with chlorine and the chemical equation is shown as below. Question I is asking you to calculate the volume of chlorine measured at room temperature and pressure needed to react completely with 0.68 gram of ammonia. So as you can see here, the only information that we have for now is the mass of ammonia. From the mass given here, we will be able to obtain the number of moles for ammonia. Now after calculating the relative atomic mass of ammonia, you will be able to get a value of 17. Dividing it with the mass, it will give you a value of mole of 0.04. So the next step would be to compare it with the ratio of the ammonia to chlorine on your equation, which is 2 to 3. So if you have a number of mole of 0.04, when you do the comparison with the value of the ratio, you will be able to get a mole value of 0.06. Now from mole, if you want to convert it to the volume, all you have to do is multiply it with the room temperature and pressure, which is 24 dm cube. After doing so, you will be able to get a value of 1.44 dm cube. However, they want you to give the answer in cm cube, so all you have to do is multiply it with 1000 to change your value to centimeter cube. So your final answer would be 1440 centimeter cube. Now this is a question from February-March 2016, question 7. Question A is related to alkane and alkene hydrocarbons. So we will be skipping it to question B, which is asking you to find the empirical formula. It says that a compound X contains carbon, hydrogen, and oxygen only. X contains 54.54% of carbon by mass, 9.09% of hydrogen by mass, and 36.37% of oxygen by mass. Calculate the empirical formula of this compound. Now when it comes to empirical formula, you need to use a method called box method. So first of all, list down all the elements that you have in the top of the box column. So over here you have carbon, hydrogen, and oxygen. On the first row, make sure you fill up all the mass for each of these elements. So for carbon, you have 54.54%. For hydrogen, you have 9.09%. And for oxygen, you have 36.37%. The next thing to do would be to find the mole for each of these elements. In order to find the mole, you need to divide the mass by molar mass. So this will give you a mole of 4.5 of carbon, 9.09 of hydrogen, and 2.27 of oxygen. Now the next thing you should do is to find the ratio by dividing it with the smallest value that you have from the number of mole. So this is what it is going to look like. You're going to divide all the number of mole by 2.27, and the reason is because 2.27 is the smallest number here. So after dividing them, you will be able to get a value of 2 carbon, 4 hydrogen and 1 oxygen. Now this is the value for how many element is present in that particular compound X. So this is what compound X empirical formula would be. The next question is saying that compound X has a relative molecular mass of 88. Deduce the molecular formula of compound X. Now empirical formula is the simplest formula for a compound, and molecular formula is the actual formula of a compound. Now from the simplest ratio, you can find the molecular mass for this compound would be 44. However, the actual molecular mass of this compound is 88. This means that the ratio to the actual molecular mass is 2. Therefore, you need to multiply C2H4O, the empirical formula, with the ratio of 2 to give you the actual molecular formula. Therefore, your actual molecular formula after multiplying by 2 would be C4H8O2. Now this is the question from October-November 2016, question 5. It says that iodine forms an oxide with the composition by mass of 76% and oxygen of 24%. Use this information to determine the empirical formula of this oxide. Now this question is similar with the previous question, and you have to use box method. So we only have 2 elements over here, which is iodine and oxygen, and the mass of composition would be 76% for iodine and 24% for oxygen. Now in order to find the mole, you have to divide it with the molar mass of each of these elements. So this will give you a mole of 0.6 for iodine and 1.5 for oxygen. So as I mentioned before, in order to find the ratio, you have to divide it with the smallest value of mole, which is 0.6 if compared with 1.5. So this will give you a ratio of 1 for iodine and 2.5 for oxygen. Since you cannot leave your answer in decimal point, what you could do is multiply it with 2 and also 2 here. This way you would get 2 iodine and 5 oxygen. Now 5 is a whole number, so this would be a better value or the right value in order to determine an empirical formula for a compound. So this means that your empirical formula would be I2O5. So this is the question from February-March 2018. Question 3. Forsterite is another rock which contains a magnesium compound. A sample of forsterite has the following composition by mass. This for magnesium, 1.58 for silicon, and 3.6 gram for oxygen. Calculate the empirical formula. Again, empirical formula means you have to use the box method. So the element present over here is magnesium, silicon, and oxygen, and the mass would be, so after filling up the mass for each of the element, you need to find the mole by dividing it with their relative atomic mass. You can get the value for the relative atomic mass on your periodic table. Now the number of mole for each of these elements would be, so remember, in order to find the ratio, what you have to do is divide each of the number of mole with the smallest mole that you have. So the smallest mole will be 0.05. So divide each of these mole with that value. Now after dividing with 0.05 for each element, you will be able to get a ratio of 2 of magnesium, 1 of silicon, and 4 of oxygen. This would give you an empirical formula of Mg2SiO4.